Alright, so here we are with 10.4, which is misleading graphs and statistics, which happens a lot more often than you'd think, which is why people think they're getting a good deal when they're not, etc. So we're going to recognize them within the statistics here. So taking a look at our first example, the graph here shows customer satisfaction with different brands. So clearly you're thinking, hey, B is really great. So explain why the graph might be misleading. So over here we've got satisfaction percent, and then we've got the brand. So the interesting part about this is that brand B is actually based on the scale of this graph. These go up by 2. So it turns out that brand B is actually only at 86% satisfaction. Brand A is at 79%. Brand C is at 81, and brand D is at 83. So if you take a look at the actual digits that are represented here, especially if we even think about grades, I mean, getting a B, 81 versus 86 is still just a B. So the graph is misleading because the scale is so small. And because the scale is small, it makes the greatest value look significantly greater. When in reality, if we look at it, I mean, the difference between the two largest are just 3%. So it's not that much. So what might someone believe because of the graph? That brand A is terrible in satisfaction, perhaps, and brand B is the best by a lot, which of course it's not. So the next ones, we've got some misleading graphs here as well. So this graph shows the amount of rainfall by year in a particular metropolitan area. So as you can see, we're trying to decipher that apparently between the years 95 to 97, we had a lot of rainfall, and then, oh my gosh, we have no rainfall. So this is the amount in inches. So we've got 50 inches up here, and then down here we've got about 25 as the lowest here. So because we learned rules about how to make graphs, what happens is you may not necessarily be looking for the fact that this graph is actually on a different scale than the lower half. So if we look at it, these numbers should have been 10, 20, 30, 40, 50 should have been here. And so what happens is because we change the scale, the y-axis So because we have multiple scales, it makes the higher amount look a lot higher than it actually is. So 50 looks very high in comparison. So what might people be influenced to believe by the graph? That recent year's rainfall is significantly lower. All right, checking out the next one. A circle graph compares each category of a data set to the whole. When any category is not represented in the graph, it may appear that another category represents a greater percentage. So again, the rule of a circle graph is that it would have all of 100%. But if you end up taking out those like teeny tiny slices just because they're so tiny, you end up making it look like the larger ones are actually more, when you're supposed to assume that the entire thing has 100%. So again, the reason that most of this is misleading is because we know the rules, like the scale needs to, or the axis needs to be on the same scale. We know that a circle graph needs to have 100% in it, but sometimes it doesn't. So, taking a look at this first one, the graph shows the allocation of the county budget. So, if we take a look at this county budget, notice that we have 10% in Parks and Rec, 20% in social services, 5% in garbage collection, and 25% in road maintenance. And so if we add all of those up together, we're going to get 60%. So this only shows 60% of the budget. So what 40% of the budget are they hiding? Perhaps it's salaries. Okay. So explain why the graph is misleading. Again, it only shows 60 of the 100% of the budget. That's really bad. Okay. So what might people be influenced to believe by the graph? That road maintenance has the most money allocated in the budget, or given. When in reality, the road maintenance is only 25%, and we're still missing the 40%. And so that could be a completely different set. And again, that 40% could make up a significant amount, especially compared to only the 25% of road maintenance within that budget. So they're hiding something, perhaps. All right. So in our random sample, all members of the group being surveyed have an equal chance of being selected. So random samples are the best way of figuring out the needs or wants or thoughts of a population, and so we take a random sample, again, where all people surveyed have an equal chance of being selected. So statistics can be misleading because of the way the data is collected. So again, we assume that a random sample is used. However, very easily, without mentioning it, the surveyors could instead just survey, for instance, all seniors instead of all students in the school. Okay. So, because we believe that they're trying to be as good as possible in their data collection, because of that, standard belief, we then are misled because they don't do it. So again, your assumptions are then twisted. So, a sufficiently large random sample is a good way to collect unbiased data. Of course, the best way would be to analyze everyone in the population, but sometimes that is not possible. For instance, that's why the U.S. Census is only given every 10 years, because we literally have to check every human in the United States, and so it ends up taking a very long time to count everyone. But of course, it is the best way to get representation of who's actually here. So, the last one here, a study of 5 households found the following number of pets per household. So, in each household, they had 2, 1, 1, 9, and 2. And explain why the following statement is misleading. The average household has 3 pets. Now, I'm not sure, again, because this study is a little bit not specific. They're talking about a study of 5 households, and unless we're talking about like a very small neighborhood, 5 households is probably very small. So it's a very small sample. Along with that, it actually seems very unlikely that all the households have a pet. Now, those of us who have pets, we all know we love them, but there are people that are allergic, and so it seems very weird that every single household, oh my god, 9, every single household has pets in it when I definitely know there are some that have 0. So I don't know if maybe they eliminated those ones kind of saying, hey, if you do have a pet, the average is 5. Not to mention, of course, that 9 is a huge outlier based on the 2 or 1. So, all right. Sounds good. So that, of course, is your misleading statistic. So most of the time, as I've mentioned already, your assumptions are that things are being done fair and according to how they should be. But of course, to mislead you, they assume you think that, and then they do something else.